Welcome to the presentation video of our Chi 2023 paper, Short-form videos degrade our capacity to retain intentions, effective context switching on prospective memory. In this work we explore the impact of short-form videos, such as those found on TikTok, on our prospective memory. With the popularity of short-form video feeds growing rapidly on social media platforms, it is important to understand the potential impact on our cognitive abilities. Social media has exploded into ubiquity in recent years and is currently used by more than half the world's population. Through social media feeds, people are frequently exposed to new information at an unprecedented rate. The information rate is also continuing to rise with the growing popularity of TikTok and other short video platforms, which displays a feed of brief, highly engaging videos. Although this high information density may be desired or even appealing for certain applications and users, it can also have serious negative consequences that we, as digital well-being and productivity researchers, we need to consider. A recent example of this phenomena are short-term videos or Reel, initially popularized by TikTok. This video format is characterized by short and personalized content that sometimes engages users for long interactions. For example, such platforms employ different design strategies, such as video autoplay, pull to refresh, infinite scrolling to maximize user engagement and attention capture. This high digital information load can cause chronic stress and to have a detrimental impact on short-term memory performance. And more importantly, we have to consider how much pervasive social media and the interruption caused by them are in our daily life. Specifically, social media distraction is the process through which social media cues attract people's attention away from the task at hand. Social media interruptions differ significantly from workplace interruptions as they are more frequent, easily over 100 per day, more complex, and less predictable. And again, they might impact the workload we experience and cause mental fatigue. In this work we focus on prospective memory. Prospective memory is the ability to remember to perform intentions, actions we care, in the future while one is engaged in performing another activity. It is a cognitive function that involves different cognitive processes such as planning, attention, monitoring, and working memory. PM is the ability to remember to perform intentions, actions we care, in the future while one is engaged in performing another activity. Individuals frequently become involved in multiple ongoing tasks after formulating an intention and, in most everyday contexts, cannot retain the intention in focal attention. Essential to everyday functioning, example, running errands or remembering to attend a meeting, or even survival. In our study, we investigated the following research question. How do different social media feeds impact prospective memory? We designed a between study design for the interruption factor. Participants were in fact interrupted by 1 out for possible interruptions. Rest, Twitter scrolling, watching a YouTube video or scrolling their personalized TikTok feed. In our work, participants were engaged in a dual task setting requiring them to perform a prospective memory task and a lexical decision task at the same time. As dependent variables we extracted accuracy in both tasks and reaction times. In the picture, you can see a scheme of the experimental procedure. Participants jointly executed 2 tasks at the same time. In the lexical decision task, they had to decide if the word stimuli was indeed a real word or an invented one. The prospective memory task required participants to remember intentions and to execute them at the proper moment. In this case, an intention is to remember to press a specific key of the keyboard when seeing a very specific word. Overall, here, participants had to remember 3 different intentions. We now gonna proceed presenting the results. We will first describe the results on behavioral accuracy for both lexical decision and prospective memory task and then move to the drift diffusion model fitting. We did not find any significant results in response accuracy before and after interruption across all the various interruption condition. Here the blue bar plots represent the accuracy before the interruption, while the red bars the accuracy after the interruption. The interruption condition did not affect the performance after the break. When analyzing response accuracy in the prospective memory task, we found that participants in the TikTok conditions performed significantly worse than participants in all other conditions. In this figure, we show the reactions times for the lexical decision task. The distribution plot shows both erroneous and correct responses. We did not find any significant results in reaction times, RT, before and after interruption across all the various interruption condition. We found similar results regarding the reaction times in the prospective memory task as well. No difference were detected before and after interruption across all the various interruption condition. However, a drastic increase in error responses can be seen in the TikTok post-interruption PM trials, which you can see in the bottom right. Finally, motivated by the results for accuracy in the TikTok condition, we decided to fit a drift diffusion model only on this condition to evaluate the performance trade-off. We chose this modeling approach as it is informative on different processing components relevant to PM. Traditional analysis approaches investigated RTs and task accuracy separately, profiting of only a subset of the available data, while the diffusion model is applied to the joint distribution of RT and accuracy data. DDM allows for the decomposition of RTs and accuracy into a set of latent parameters representing underlying cognitive processes such as task load, evidence accumulation, and decreased cognitive capacity. From the drift diffusion model, we can extract 4 parameters underlying specific feature of the decision-making process. As an interpretation, the drift rate informs the speed and direction of information accumulation. The drift rate can be interpreted as a measure of subjective task difficulty. Higher, absolute, drift rates indicate less demanding tasks. Second, the decision bound characterizes the time needed to make a decision, and with a larger decision bound, more effort is expected to form a decision. Here, smaller values imply shorter information uptake and increased erroneous responses. Third, the non-decision time captures the time spent for stimulus processing, but unrelated to the decision, such as perception of the target stimulus or execution of the response and stimulus encoding time. Lastly, the variance component models the uncertainty of a decision process. Thus, an increased variance could result in more diverse reaction times needed to perform a decision when the PM stimulus is presented. The TikTok condition showed a significant smaller drift rate as compared to all other conditions. After the TikTok interruption, the task was subjectively harder for participants. The TikTok condition showed a significant increased variance as compared to all other conditions. After the TikTok interruption, participants were more uncertain when performing a decision in the PM task. Decision bound was significantly smaller in TikTok as compared to the rest. Higher effort in performing a decision after TikTok interruption. Non-decision time was significantly smaller in YouTube when comparing the pre- and post-interruption measures. We will now reflect on what are results and which are the critical take-home messages. Short-form videos represent multimodal and emotional stimuli that capture our attentional resources and limit our capacity to remember intentions. This is because such dynamic visual and auditory features require attention focus for effective information processing during video watching. Participants were vulnerable to the interruption and not ready to resume the task, as they were cognitively engaged with the interruption. DDM analysis showed that TikTok interruption slowed information processing efficiency and made harder for participants to make a decision, requiring more time. Short-form videos increased the memory demand on participants, making it harder to process each alternative, leading to reduced evidence accumulation rates for making a decision. We showed that interruptions with short-form video significantly degrade PM performance. This type of effect in the real world is generally not desired and could be classified as a dark pattern. We envision 3 possible solutions that might counteract this effect. First, we know that reminder systems have been shown to support rehearsal for highly specified intentions but could help users remember tasks after a social media interruption in a productivity context. Alternately, proactive reminder systems or digital self-control tools can anticipate the social media feed engagement and suggest positive and healthier interruptions. This would, first, support the overall efficiency of digital reminders for task management and, second, overcome challenges in support of PM as intentions are generally triggered by either specific events or times. Then, we suggest to leverage the impact of short-form videos to intentionally make users forget information. Aside from avoiding adverse effects, technology designers could exploit PM degradation by intentionally engaging short-form videos as interruptions in strategic situations. Distraction is a recommended game design technique to increase immersion or the impact of surprising scenes. Second, as we saw social media interruption lead to forget informational content. We can combine this in an effective computing paradigm that monitors when a user is unhappy and intervenes with short videos to disrupt their memories. Finally, designers could employ short-form videos to help users transfer their focus to a new task. Research on task switching shows that the initial task interferes with the second task because users maintain residual attention on features that are no longer relevant. Short-form videos could then support users to switch their focus to a new task, reduce the residual attention on the previous task, and thereby reduce the time required to fully focus on the new task. In conclusion, our research indicates that short video streams like TikTok have a negative impact on PM performance, leading to a compromised speed/accuracy trade-off compared to other platforms. However, we have identified specific guidelines that can help counteract this effect and enhance user experience and digital well-being in productivity settings. By following these guidelines, businesses and individuals can make the most of technology while minimizing its potential negative impact. As HCI community, we can work together to create a healthier and more productive digital environment for everyone. Thank you for watching this video. Please reach out to know more and have a read at the paper in the ACM Digital Library.